Welcome to Rounding Your Calculations video. Calculations that we perform must have answers that reflect the certainty that we can reasonably expect in our answer. Otherwise, our answers can be very misleading. To achieve this, we must round our answers to our calculations appropriately. Let's look at an example to see why rounding is important. I have measured a volume of baby oil in a beaker. It's about 25 milliliters. And I find out from the manufacturer, who's gone through rigorous testings of their baby oil, that the density of the baby oil is 0.8751 grams per milliliter. I can do a simple calculation, mass equal volumes times density, to find the mass of that baby oil. And I've done it right here below. Remember, in doing our calculations here, I am expressing my data as unit factors, which expresses them as basically a fraction in a fraction form. This will help with our calculations. So I put the numbers in my calculator and I came up with 21.8775 grams. But can I really express my answer to this degree of certainty? Well, I hope you kind of figured out that no, I probably can't. I don't know that number that well. But if I don't know that number that well, how do I decide how I can express this number? Well, let's take a deeper dive into our individual data points. 25 mils is our first data point. Well, I just measured that in a little beaker. It's very approximate. I'm only comfortable with saying it's 25 milliliters. The manufacturer data, on the other hand, the 0.8751 grams per mil, that's a lot. I'm a lot more certain about that. They put a lot of time and energy into coming up with that number. So one of our rules here is I need to round my answer to reflect the certainty of the least certain measurement. Maybe you've heard the expression, a chain is only as strong as its weakest link. Think of the chain as that calculation. The weakest link is the least certain measurement. And I hope you can agree with me, in this particular instance, the 25 mils is our weakest link. Now we will formulate some rules to round our answers so that they properly reflect the certainty that they are due. In this class, we will deal with two different categories of calculations. One involving multiplication and division, and the other category involving addition and subtraction. In later classes, these operations may be mixed, but not for this class. For calculations involving multiplication and division, the answer to that calculation has only as many significant figures, so this is what we're looking at, significant figures, as the measurement with the lowest number of significant figures. This number reflects the number we have the least certainty with. If you need review with significant figures, there's a video on this topic. So let's look at our old friend, the baby oil. Remember, we did our calculation. We already decided that 25 milliliters was our number or our data point with the lowest certainty. We went ahead and figured out the number of significant figures. Two significant figures, the 2 and the 5. Our density, remember this is a leading zero, has 4 significant figures, all of the non-zero numbers. When we do our calculation, we get this from our calculator, but our number must be rounded to the lowest number of significant figures. That's the 2 significant figures. Well, this actually has 6 significant figures right here. I have to chop off my answer right here at the decimal point. My 8, because it's 5 or higher, means that my 1 must now round to a 2. So if I'm going to report it, it will be 22 grams and have 2 significant figures. Let's try some examples on your own to test your understanding. Note that the first example here is in scientific notation. Make sure that you can handle scientific notation on your calculator. Pause the video here and perform the calculation, rounding appropriately. Resume the video to check your work. Come back. Let's check your answers. In our first example, you see the pink numbers underneath the individual data points give you the number of significant figures. It's a division calculation, so we're looking at significant figures. Our lowest number of significant figures is this first one. It has 2. So if I do my calculation, this top number is what I get from my calculator, but I have to round it appropriately. I have to round it to 2 significant figures. That means I have to cut off my answer right here, right after the 6. 3 is lower than 5, so 6 stays the way it is. My answer rounds to 560. My second example, again, I put my significant figures, the number of significant figures underneath each data point. I have 3 significant figures for my first one and also my second, but notice my last one, these are a chain of multiplication, so I look at sig figs, only has 1 significant figure. That leading 0 is not significant. So I do my calculations. Again, my calculator gives me the 23.544, but that has 5 significant figures. I have to cut it off right behind the 2. The 3, again, is lower than 5, so 2 stays the way it is. I now have an answer of 20. That's rounded appropriately. If you need more practice, there are blue practice sheets in your notes. Thank you. Let's look at our second category of calculations. That is calculations involving addition and subtraction. The rule for these types of calculation is the answer of an addition-subtraction calculation can only have as many decimal places as the measurement with the lowest number of decimal places. Notice now we're looking at decimal places, not significant figures. Remember to tie decimal places with addition-subtraction calculations. So let's try an example to illustrate this. Notice I have 3 different measurements here. Another thing I want to point out here is when we do addition subtraction, here I've decided to go ahead and put in some units. Grams, that's a unit of mass. Notice all 3 numbers that I'm adding together all are in the same unit of mass, that is grams. I cannot add, for example, grams to milliliters. Milliliters is a volume, so it's different. So I'm adding the same units together. Okay, so let's look at our example. Here we have a number that has 2 decimal places. The 6 and the 7 are in decimal places. Our second number, we have 1 decimal place. It's 4.5. And our last number, we have 3 decimal places. So I'm going to do my calculation. I get 26.953 on my calculator, but now I have to round appropriately. Now I'm going to look at decimal places, not significant figures. The lowest number of decimal places in my calculation string is 1 decimal place. That comes from my 4.5. So my answer must have 1 decimal place. I have to chop my number off right after the 9 in order to have 1 decimal place. But look what happens. I did this on purpose to show you something that's a little bit of a trick. My 5 would mean my 9 needs to round up to a 10. So that becomes 27, but I can't just put 27. I have to put 27.0. I still need my 1 decimal place. Let's try some examples on your own to test your understanding. We have 2 examples here. Both involve addition, subtraction, and calculations. Pause the video, perform the calculations, and round appropriately. Resume the video to check your work. Welcome back. Let's check your work. In our first example, we have 3 numbers. Notice I've mixed the addition and the subtraction. That's fine. Our first number, we have 0 decimal places. Nothing comes after that 7. There's nothing after a decimal. Our second number, we have 2 decimal places, the 5 and the 2. And our third number, we have 3 decimal places. So our lowest number of decimal places will be 0. If I put all those numbers in my calculator, I get this top number, 1,227.997. I'm going to have to chop it right after that 7, so I don't have any decimal places. The 9 is 5 or greater, so that means the 7 rounds up to 8. My properly rounded answer is 1,228 with 0 decimal places. Our second example, the first number has 3 decimal places, and our second number has 2 decimal places. 2 is smaller than 3, so our answer has to have 2 decimal places. I put everything in my calculator, and I get 0.138. That has 3 decimal places. I need 2, so I have to chop it after my 3, but my 8 says, oh, I am 5 or greater, so 3 must round up to 4. My properly rounded answer is 0.14. That has 2 decimal places. Hopefully you did well on this. If not, go ahead and do those blue practice sheets in your notes, and we will wrap up with a review. Let's wrap up with a quick review. Measured numbers are never perfect. They always have some uncertainty. There are numbers, however, called exact numbers, which have an infinite number of significant figures. These are numbers which are based on a definition or something like that which is exact. These exact numbers will never play a role in how we round our calculation. To review, multiplication and division calculations, symbolized here, you round to the lowest significant figure within your calculation string. Addition and subtraction, you round your calculation string to the element with the lowest number of decimal places. So think multiplication, division, I look at significant figures. Addition, subtraction, I look at decimal places. Thank you.